I'm off to see a guy who was one of the first people to think about this strange idea. I'm supposed to meet him at 4 o'clock at his apartment on 5th Avenue and 93rd Street on the second floor. Now, in order to get to this meeting, I need 4 pieces of information. One for each of the 3 dimensions of space, a street, an avenue, and a floor number, and one more for time, the 4th dimension. You can think about these as the 4 dimensions of common experience: left, right, back, forth, up, down, and time. As it turns out, the strange idea that there are additional dimensions stretches back almost a century. Our sense that we live in a universe of 3 spatial dimensions really seems beyond question. But in 1919, Theodor Kaluza, a virtually unknown German mathematician, had the courage to challenge the obvious. He suggested that maybe, just maybe, our universe has one more dimension that for some reason we just can't see.
Look, he says here, I like your idea. So why does he delay?
You see, Kaluza had sent his idea about an additional spatial dimension to Albert Einstein. And although Einstein was initially enthusiastic, he then seemed to waver and for 2 years held up publication of Kaluza's paper. Eventually, Kaluza's paper was published after Einstein decided extra dimensions were his cup of tea. Here's the idea. In 1916, Einstein showed that gravity is nothing but warps and ripples in the 4 familiar dimensions of space and time. Just 3 years later, Kaluza proposed that electromagnetism might also be ripples. But for that to be true, Kaluza needed a place for those ripples to occur. So Kaluza proposed an additional hidden dimension of space. But if Kaluza was right, where is this extra dimension? And what would extra dimensions look like? Can we even begin to imagine them? Well, building upon Kaluza's work, the Swedish physicist Oscar Klein suggested an unusual answer. Take a look at the cables supporting that traffic light. From this far away, I can't see that they have any thickness. Each one looks like a line, something with only a single dimension. But suppose we could explore one of these cables way up close, like from the point of view of an ant. Now, a second dimension, which wraps around the cable, becomes visible. From its point of view, the ant can move forwards and backwards, and it can also move clockwise and counterclockwise. So, dimensions can come in 2 varieties. They can be long and unfurled, like the length of the cable, but they can also be tiny and curled up, like the circular direction that wraps around it. Kaluza and Klein made the wild suggestion that the fabric of our universe might be kind of like the surface of the cable, having both big extended dimensions, the 3 that we know about, but also tiny curled up dimensions, curled up so tiny, billions of times smaller than even a single atom, that we just can't see them. And so our perception that we live in a universe with 3 spatial dimensions may not be correct after all. We really may live in a universe with more dimensions than meet the eye. So what would these extra dimensions look like? Kaluza and Klein proposed that if we could shrink down billions of times, we'd find one extra, tiny, curled-up dimension located at every point in space. And just the way an ant can explore the circular dimension that wraps around a traffic light cable, in theory, an ant that is billions of times smaller could also explore this tiny, curled-up circular dimension. This idea that extra dimensions exist all around us lies at the heart of string theory. In fact, the mathematics of string theory demand not 1, but 6 extra dimensions, twisted and curled into complex little shapes that might look something like this.
If string theory is right, we would have to admit that there are really more dimensions out there. And I find that completely mind-blowing.
If I take the theory as we have it now literally, I would conclude that the extra dimensions really exist. They're part of nature.
When we talk about extra dimensions, we literally mean extra dimensions of space that are the same as the dimensions of space that we see around us. And the only difference between them has to do with their shape.
But how could these tiny extra dimensions, curled up into such peculiar shapes, have any effect on our everyday world? Well, according to string theory, shape is everything. Because of its shape, a French horn can produce dozens of different notes. When you press one of the keys, you change the note because you change the shape of the space inside the horn where the air resonates. And we think the curled up spatial dimensions in string theory work in a similar way. If we could shrink down small enough to fly into one of these tiny, six-dimensional shapes predicted by string theory, we would see how the extra dimensions are twisted and curled back on each other, influencing how strings, the fundamental ingredients of our universe, move and vibrate. And this could be the key to solving one of nature's most profound mysteries.